Okay, hello, you're welcome to Time Zones office hours for week one, and it's a great honor having you around. Thank you for deciding to be a part of the introduction to programming for data science bootcamp, and this is just a summary of what happened in class yesterday. So I promised you I was going to be doing this periodically so that you can, especially if you missed the class, you can review the video and also review this one, and you can have a more broad view of what happened in class yesterday. So yesterday we began to talk about introduction to programming for data science, and the first question you would want to ask is, what is data science? Simply, I like to call data science science that is all about data. And why do I say science that is all about data? It's very simple. The thing is, there is so much data flying around right now, and the skill that is going to make you outstanding in this present generation, this information age that we are in right now, is your ability to help people make sense of the amount of data that is being thrown at us right now. There's so much data, but so many people do not know how to make sense of that data. And I have this diagram from one of the books I'm working on currently. I try to explain data science. Data science begins with raw data. Raw data are all the data that you get from maybe your Facebook likes, your Instagram page, maybe it's a sensor, maybe whatever it is, whatever kind of data you collect. Maybe you use a questionnaire, you do a survey, you have a system in your office, an ERP, an accountant software, whatever it is. Every app in your phone, practically all apps in your phone, generate data. Now, all of this raw data that is generated need to be channeled into some form of repository or something that helps with data retrieval, helps make the process of data retrieval and analytics very easy. And that is where data engineering comes in. Data engineering refers to all the processes that you use to make data, to get data ready for analytical work. It has to do with things like storing the data. It has to do with everything in that data pipeline, engineering pipeline, so this is where we'll talk about things like database design, because raw data has to be captured in such a way that you can pull it. So after data engineering, analytics is the place that takes practically 80% of your time as a data scientist, because analytics is where you try to prepare the data for consumption. And I always like to say is that analytics is like the role of a chef, because every data that is being prepared, every data that is being generated, has just two destinations. Data can be consumed by machines or can be consumed by humans. When they are consumed by computers, it's called artificial intelligence. And the process by which analytics is done so that computers can consume this data that is being received is called machine learning. What happens in machine learning is that we take some pieces of data, try to explore, try to analyze it, and try to prepare it in such a way that when we feed it to the computer uses it as a training set to train itself and learn from that data set, so that next time when the computer sees that kind of pattern emerging in any form of data that is receiving, it knows what to do with that data. So that's what happens in machine learning. In machine learning, we take data and we do some analytical work on the data and try to prepare it for consumption for computers. But the other side of analytics is where we prepare data for human consumption, and that is called business intelligence. What is business intelligence basically? Business intelligence is the preparation of data, analytical work being done on data to be displayed to humans for their consumption in the form of visualization. See, humans consume data in visual form. But practically every data that is analyzed upon is presented to the human being in visualizations. So visualization include things like charts, things like graphs, things like reports, things like whatever. But all of those visualizations help this process that we call business intelligence. So this is what data science is. Data science is your ability to, it's you trying to get data, raw data, and trying to exploit, trying to understand this data, trying to analyze it, and trying to arrive at some form of intelligence from that data. So that's practically what data science entails. So whenever you hear somebody say, I'm a data scientist, this is what the person is telling you. He's telling you that I either prepare machine food by way of machine learning, or I either prepare data for human consumption to create business intelligence. Right? So that's basically data science. There's really nothing else that is data science that is not captured here. All right. So like I always say, analytics is where it always happens. It's where it all happens. Analytics is the most important process in data science. Without analytics, humans and computers alike cannot make sense of data. Analytics is the process that helps ensure that the data is broken down, conforms to some certain principles that you will get to know much later, and so that when the computer is fed with this, or when humans are fed with this information or this processed data, they can make the right decisions. So there are various analytical tools that exist, and we have things like Microsoft Excel. Microsoft Excel is a spreadsheet. Amazing is a spreadsheet, but it is really not suitable for analytics for machine learning. Now Microsoft can help you, Microsoft Excel can help you prepare visualizations, amazing visualizations for human consumption, and humans can make sense of what you do in Microsoft Excel. But many times Microsoft Excel is not suitable for analytics for machine learning. You will need to do a lot of workaround, and that is not really a good place to be as an analyst. You already stressed, and you don't want to add the stress of trying to do a lot of working around by using Excel to prepare data for machine learning. Now there are also some other tools like Power BI and Tableau, but this is it. Power BI and Tableau are both visualization tools, and they share the same limitations with Excel. They do well for business intelligence. They do well for data consumption by human beings, because these tools, they create visualizations through which humans consume data. But then the problem is they do not serve very well in the purpose of machine learning. So you see, on the analytic side of things, like the graph we just saw, the diagram we just saw in the previous slide, you would notice that it seems like there's an abundance of tools that serve human analytics. We have Tableau, we have ClickSense, we have a lot of all of this trying to satisfy the visualization market. All right, but then the machine learning side of things is a bit quiet. The amount of buzz that we get is not as high. You see different things. We see different things coming up every day, different BI tools, business intelligence tools coming up per day, different marketing gimmicks and all that. But again, you will now want to ask yourself, just like we have Excel for and Power BI and Tableau for visualization, can't we have something that is that intuitive for machine learning, so that we can also do machine learning? And yes, there are other tools. For example, there are Azure AI and Google ML, and some of these other tools are drag and drop tools, which means that they are intuitive, just like Excel, But then The problem is that they are rendered with the SaaS, that software as a service business model, which means that you have to pay heavily to use these things. And when you are just maybe one analyst or one analytics person in your company, no problem, you're fine. But the moment you need 10 licenses, 20 licenses, the bills begin to pile up really, really, really fast. So, open source to the rescue. And what is open source? Open source are free to use tools that are made readily available for everybody without any copyright or any of these patent related, intellectual property related encumbrances. So, what are the various open source tools that we have? Well, can I say sadly or unfortunately or fortunately, I don't know which one now. Most of the open source tools that we have are programming languages. Most of them. So, you either have to do it using Python, Java, Julia, C, whatever language you're comfortable with. These languages are just tools, all right? And they are open source tools that you use to do your analytics. Now, why do we use programming languages in data science? The first is cost effectiveness. Like I explained to you, it can really become a problem doing BI or analytics with these vendor originated tools like Power BI, Tableau, and all that. And the reason is simple, because these guys are in business and they have to recover all their costs. So, for example, right now, to get a Power BI Pro license, you need to pay like $10 per user per month. And then if you have maybe 15 users, all right, in your company, then you're looking at around $150 per month. If you multiply that by a whole year, the bills begin to be very, very relevant. Okay, and you know, most of these things that are rendered as software as a service are billed on a monthly basis. So that means the bills can rack up real quick without your planning it. Okay, so that's one of the reasons we use programming languages. It's cost effective. Another reason we use programming languages is that most times they're generally available. Anybody can go online and download Python, you can download Java, you can download anything, any of these languages, and begin to use them. All right, they're generally available. And the third is that many times you probably have encountered these things somewhere. All right, so it's easy to just transfer that skill that you learned somewhere, you know, into the data science field. So let's say you were probably a developer or something, and you had been using Python, Java, or whatever. When you come into the data science field, automatically it becomes very easy for you to just come with that knowledge you had when you were a programmer or something into the data science field, you know. So it makes it easier, it reduces the barrier to entry for you. So why do we use Python in data science? The reason is very simple. Python has a very low entry barrier. Python is like the entry-level programming language everybody uses. The moment you just decide you want to program, I think the best thing you should do is to start learning Python. Python is very readable. Python is easy to learn. Python is friendly, is user-friendly, right? So it's because of these things that people, you know, let's just use Python. Another thing about Python now is that because of its low entry barrier and the fact that a lot of people use it, what has happened is that over time, people have begun to build libraries. What are libraries? Libraries are a collection of pre-written codes, all right? And these libraries help you to perform tasks faster. I really cannot imagine a world without libraries. For example, look at this Excel sheet. On column A, we have the names of the employees. On column B, we have their salaries. Now, if I want to get the total of the salaries that we pay, all I just need to do is equal to sum B2 to B5, and I get it. You see that sum function there? That sum function is actually a library. It's actually something that has been pre-written before. if Excel did not put that sum function there, you would have actually needed to write something like this code you're seeing now for you to be able to achieve this thing that you just did. So now imagine for every function, maybe you want to do sum, you have to write this long code. You want to do average, you have to write another long code like this before you use it. You'll notice that before you can do one or two things, the whole day has passed. So what these libraries do, like this sum function and all that, what they do is that they make your life easy so that you don't have to repeat yourself, and which is one of the very, very important cardinal principles of programming. Don't repeat yourself. It's called the DRY principle, DRY. Don't repeat yourself. So you have to, as much as possible, ensure that whenever you have something that requires repetition, it becomes a library. So what happened was that a lot of guys began to build libraries in Python. So we began to see libraries for things like regression, libraries for things like calculation of formulas, libraries for, so people decided to just keep building and building and building and building. And as the last time I checked, I think Python has over 300,000 libraries or something like that. I'll need to reconfirm that figure. All right. So just imagine how easy things have been made for you. Right now, there's almost nothing that doesn't have a library in Python. Whatever you need, just think about it. I think someone somewhere has written a library about it. And if you just look very deeply, you'll see a library. Okay, so that's why Python is the choice language for analytics. When we talk about analytics, we're talking about both machine learning and human consumption visualization. So it's the choice open source tool. Now somebody will tell me, what of Excel? Excel is not open source really. Excel, you pay for it. Power BI is not open source, you pay for it. Tableau is not open source, you pay for it. All right. So Python is like the only one you really do not pay for, and you have access to all those energies, all those functionalities. So that said, every library that you need is imported into the Python program, all right, and you start referencing it as you code. So what is programming basically? Programming is the art of processing data through a computer by giving the computer a list of steps to follow. And like I always say, the computer does not do anything without programming. Whether you're doing something on Excel or you're creating a presentation in PowerPoint, or what is happening is that programming is taking place. Don't let the user interface that you're seeing confuse you, because somebody will say, hey, I'm not programming, I'm using the spreadsheet. No, you're actually using the spreadsheet to manipulate what you're seeing, the user interface. What is going on under the hood is heavy programming. Heavy programming. And that's why, for example, in Excel, when you record macros, you are actually taking steps. But Excel is now showing you the programming behind all those steps that you're taking, so that if you want to replicate it on your own, you can go ahead and replicate it. That's what happens when you use user interfaces like that. Programming is what drives the computer. Now, is programming hard? Well, programming is simple but not easy. Simple in the sense that every act of programming just has two key underlying concepts, and we're going to look at those two keys shortly. In programming, once you can get the concept, what is left is just syntax. And that's why the class started with a language agnostic introduction to programming, because we just want you to get the concepts of how programming works. Once you get the concept, you can apply that concept in Java, you can apply it in C#, you can apply it in C, you can apply it in Python, you can apply it in Julia, you can apply it in R, in whatever kind of programming language it is, VBA, that you want to apply it. But you just need to get the concept. And it is the concepts that we are trying to help you get right now. Once you get the concept, what is left is just syntax. So while Python might say print hello world to output the text hello world on your screen, Java might say something like public void arg strings prints hello world, all right, or system.line.print or something like that, if I remember very well. Okay, so all that is just syntax. And to overcome the syntax barrier, you have things that are called IDEs, integrated development environments. These IDEs are tools, they're like softwares that help you overcome syntax barrier. in the sense that most of the syntaxes, most of the syntax have already been programmed into the system. So if you just notify the IDE that you're using Python, what the IDE does is that it automatically reconfigures the whole thing for you so that it's expecting Python keywords from you. And then when you type anything that is not Python, the IDE would highlight it for you and say, this is wrong, this is not how to put it in Python, and make a suggestion for you once it's a good IDE. All right. In fact, the IDE will guide you on things like the arguments, the parameters, and things that should be in whatever program you're trying to write. So all you need to do is just to know the concepts. Once you know the concepts and you have a good IDE, you have made your learning journey very, 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 very easy for yourself. Okay. So what are the two key concepts in programming? They're very simple. The first is variables. The second are control structures. What are variables? Variables are attributes, behaviors, or whatever it is that, I'm sure we'll talk a bit more about this in the second session. I don't want to make this too technical, but what is a variable? A variable is like a container, a container that you use to, house something, an idea. For example, if I say car, if I tell you I just bought a car, your mind does something very amazing. Your mind just gives you a picture of something that has wheels. Because I've not even told you the kind of car I bought. I just told you, man, I just bought a car. Immediately, something just happens in your mind. You just picture something that has wheels, that has an engine, that can move around and stuff like that. That word there, car, is actually a variable because it can be anything. It can be a salon car, it can be a sedan, it can be a bus, it can be anything. Once I just say car, it can be hatchback, it can be whatever. So that's what a variable is. A variable is a container that can carry any value at all of something, of an idea or a concept that you want to bring into your programming. So if your programming is about maybe salary, the moment you say salary, what should the computer think of? That's exactly what you're trying to do, because the computer is dumb. Actually, the computer doesn't know anything. You have to instruct the computer step by step in everything the computer is doing. So at every point in time, you need to coach the computer, and that's why variables are like the bedrock of programming. It's like one of the key concepts, because you need to tell the computer what to expect when you say something. So when I say house, the computer doesn't know what a house looks like. I need to tell the computer what a house looks like. So I'm going to now tell the computer things like the attributes and the behaviors of a car, so that when he sees that house, he knows, okay, a house has a window, it has a paint, it has doors, it has. So by doing that, I am teaching the computer, and that's what programming is. You're directing the computer, you're telling the computer what to do. All right. So it's very key you understand variables and how they work. And then the next concept you need to understand are control structures. And there are just three control structures. Control structures determine how the variables in your program interact with each other. That's just basically it. Remember, I told you there are only two concepts in programming, really: variables and how they interact with each other. So I tell the program that I have two variables, car and driver. So how does the car and the driver interact with each other? That's exactly what happens in control structures. Now, in control structures, there are three things that make up control structure. The first is the sequence structure, which is usually the flow. All right, I'm going to show you an example of this shortly. And then the second is conditional, which is where you try to make a decision based on two or more conditions that are available to you. Right? For example, I just said variable 1 is car, variable 2 is driver. Now, what happens when the driver gets to the door of the car and puts in the wrong key? Okay, so that's the conditional, because I'm going to tell the computer, if the driver puts in the wrong key, send a warning alarm or sound a warning alarm saying wrong key, wrong key, wrong key, else. allow the car to open. That's basic programming. That's what programming does. And then what happens is that by the time you're done with conditionals, then the last thing that is part of the control structure is called looping. Looping is a means of repeating an action that happens between variables and one variable and the other. So let's take a good example. Pretend for one moment that you just woke up from sleep and you're about to go to work. What are the normal things you do? The normal things you do are probably, number one, you grab your phone. If you're like the regular person, once you wake up, the first thing you do, you just pick your phone. I don't know why we do that, but I think we're spoiled. All right. So the second thing you want to do is to open all the social media. You want to check your WhatsApp, Telegram, you want to check your LinkedIn, you want to check your Instagram, you want to check your Facebook. You want to just catch up on everything that you think you have missed. All right. And then when you're done with that, you decide if the posts are really interesting and what's your reply. And then you get up from bed finally and you do your personal hygiene, you brush, you shower, you get freshened up, you open your wardrobe and you decide which clothes you want to wear to work. And then you grab your car keys and head for the door. And hey, the gate is locked. So what do? If you're in like this part of the world where we are in, you keep knocking on the security gate until it's open, or you pick your phone and keep calling the security person until he comes to open the gate or something. So if you look at these steps that we take is the sequence. I told you about control structures. This is the sequence. And what are the various interactions of the variables? The first is this. You will notice that grab your phone is a behavior. We also call behaviors function if you like, all right? Now, grab your phone, that's a function. So when we're coding a person variable, we can declare the variable and say, okay, maybe let's just call you Gloria. All right, so Gloria equals person equals to Gloria. All right, and then we now declare the behaviors that we expect from Gloria when she wakes up. Okay, so when Gloria wakes up, Gloria dot grab phone. So we'll go to the computer now, tell the computer what the whole grab phone thing entails. And then Gloria dot open social media. We also tell the computer what Gloria is likely to do when Gloria opens her social media. All right. Now, the third point, which is where you decide if what you're looking at is interesting and what's the reply, is now a selection and decision stuff. And you'll see that in that's one of the control structures where you have to make a decision. So you have to now ask yourself, if these posts are interesting, and what's my reply? What should I do? Reply, else, delete. All right. So those are selection and decision you have to do. Then from there, you have to now take up another behavior again. Get up from the bed, do your personal hygiene. All of these are functions. All right. In programming, we call them functions. And then you open your wardrobe and you decide which clothes to wear. Again, you now have to ask, if today is, for example, in Nigeria, the normal policy is in the average workplace or the regular workplace is Monday to Thursday, you dress up, on Fridays, you dress down. So when you open your wardrobe, you now have to ask yourself, if today is Monday, dress up, else, dress down. Okay, no, else. If today is Tuesday, dress up, else. If today is Wednesday, dress up, else. If today is Thursday, dress up, else, dress down. So it means that Monday to Thursday you dress up, and then on Friday you dress down. All right. So all of those are the things that you have to decide on. Whenever you have to decide on something, that is when the conditional structure comes in place. And then you now grab your keys and you head for the door, and the gate is locked. When the gate is locked, you want to get your security person's attention. There are two ways you can do it. You can keep knocking until the security person opens the door. So if you want to translate this into programming language, what this will mean, it will read something like, for every time the door remains closed, keep knocking until until the security person comes out. That's basically what it looks like in programming language, and you're going to start seeing all of this practically, because programming is really practical, and that's why it's simple, all right? But it's not easy because there are syntax rules that you have to learn. You have to learn that, okay, for example, in Python, this has to be square brackets, this has to be curly braces, this has to be inverted commas and all that. So that's what makes programming a bit like on the tough side. But besides that, programming is easy, and that's why I told you when we started that once you can understand the concepts, every other thing in programming is just syntax. So with that, we've come to the end of the first session, and if you have any questions or any further things that you need clarification on, please do not fail to reach out to us at TimeZone. Thank you very much.